So what we have done in this setup is a 5 kV 24 volt inverter. So this is the 5 kV inverter. It has an onboard button here where I can put it off. This system is off. And if I also press the onboard button again, the system comes off back. You see, this is the level of the charging, this is the level of the charging, and this is the level of the charge. So the whole total load here is now up to 15%. So as I said earlier, it has its own onboard breaker. One is for the input from the power holding company. The other one is supplying power out. If I put it on back, can you see that the light is off now? Despite the fact that the inverter is on. Come and show them the inverter. The inverter is on. So I want to put the inverter on now. I will ensure that these two breakers are on. When I put it on, can you see that the inverter is powered? So, but it's not advisable for you to always encourage your customers to use the onboard breaker. So we make provision for two other breakers here. We have the down one is meant for the output coming out from the inverter, supplying the load of the building. So if I put this one off now, the whole light goes off. And if I put it on back, the light goes on. And during rainy season, when there is rain, and you don't want excess voltage to charge up your inverter or to destroy your inverter, you can also put it off here. The upper part is meant for the charging of the inverter. So currently there is no electricity. Can you see NEPA start generator? So if you want to charge this, if we put on the generator and we don't want the generator to charge the inverter, probably maybe because the generator capacity is lesser than the inverter capacity, we put it off here. We put it like this, we put it here. So if we now want it to, it means the generator is only running on the whole building. The inverter is on bypass. So now if I want the generator to charge back the inverter, I put it on here and I leave this one here, provided that I want the generator to power the house. But if I want the generator to also run alongside with the inverter, I bring it down here. Another advantage of putting it on the inverter is that when light goes on and off, the inverter will always be running. But ensure that when you want to put it on inverter, if you notice, the moment I put it on inverter like this, there is a spark. To avoid this spark, you ensure that your breaker here is off. You put it on here. So you put on your breaker. You ensure that anytime you want to put it off, you want to put it on inverter, you ensure that this is off. You bring it down before you put on your breaker so that there will be no spark here. So thank you very much.